In today's lesson, we'll be learning about the point of intersection with a focus on equations. In a previous lesson, we learned that a point of intersection can be found in 4 different ways. Today, we'll be finding the point of intersection with the method of substitution, which involves using equations and algebra. We want to find the point of intersection of this blue line and this red line. The blue line has a y-intercept of positive 4, and it has a slope of negative 0.25. In its table of values, again, you can see that it has a y-intercept of positive 4 and a slope of negative 0.25. In this red line, you can see that it has a y-intercept of positive 1 and it has a slope of 0.5. In its table of values, you can see again that it has a y-intercept of positive 1 and a slope of 0.5. As discussed in a previous lesson, we can find a point of intersection with a table of values. And if you look closely, you'll see that the point of intersection is 4 and 3. Therefore, these two lines meet at 4 and 3. But another way of finding a point of intersection is with a graph. I'm going to graph both these table of values and I'm going to look for the point of intersection. The blue and red line meet right over here, which makes this the point of intersection. The coordinates or address of this point of intersection are 4 and 3, which is the same point of intersection that you found earlier with our table of values. So we found the point of intersection with a graph, with a table of values, and now we're going to use the method of substitution, which involves using equations and algebra. The first step in the method of substitution is to convert both equations to slope-intercept form, which is y equals mx plus b. The blue line appears to be already in slope-intercept form. Meanwhile, the red line also appears to be in slope-intercept form, which means we don't have to do anything for this first step. Sometimes you do, sometimes you don't. Our second step is to substitute one equation into other equation and solve for x. We can begin this step by choosing one of these lines to work with first. You can either choose the blue line to work with first, or you can choose the red line to work with first. It doesn't matter which line you choose to work with. I'm going to choose to work with the blue line, which means I'm going to rewrite its equation exactly as you see it. Y equals negative 0.25x plus 4. This next step is a little bit confusing. We already know that y is equal to 0.5x plus 1. We also know that there's a y right over here. What we're going to do is we are going to substitute or replace this y with 0.5x plus 1. So the y isn't there anymore, and now we have 0.5x plus 1. Everything on the other side of the equation stays exactly the same. At this point, you want to look for like terms. You'll notice that positive 1 and positive 4 are like terms, while 0.5x and negative 0.25x are like terms as well. Like terms like to be together, but also, generally speaking, you want to keep numbers and variables on separate sides of the equation. So I'm going to move these two terms together, and I'm going to move these two terms together, which makes variables and numbers on separate sides of the equation. Remember, when you move terms across an equation, they no longer stay the same. They become the opposite. 0.5x stays the same since it hasn't moved. This is going to become positive 0.25x since it has moved across the equation. And the positive 4 stays exactly the same since it hasn't moved. And the positive 1 now becomes negative 1 since it has moved across the equation. I'm going to erase this positive sign since it's not really needed anymore. We want to simplify both sides of this equation now. So on the left side, 0.5x plus 0.25x is going to give you 0.75x. And on the right side, 4 minus 1 should be 3. We'll now want to divide this side by 0.75 because the opposite of multiplying by 0.75 is dividing by 0.75. And what you do to one side of an equation, you must do to the other side of the equation. These 0.75s are going to cancel out, which leaves an x, and 3 divided by 0.75 gives you 4. So x is equal to 4. We're not quite done. A point of intersection has 2 numbers in it. We only have one of them. We now need to find the other one. The third step is to substitute your value of x into any equation and solve for y. We just found x was equal to 4. Which means we can put that number into our blue line or we can put that into our red line. It doesn't matter, the choice is up to you. I'm going to choose to use my red line. X was equal to 4, which means I'm going to replace this variable of x with the number 4. So that becomes y equals 0.54 plus 1. Now this looks a little bit strange because this looks like 0.54, but there really is a multiplication between these two numbers. In my next step of work, you need to follow BEDMAS, which means you need to multiply these two numbers before adding. So 0.5 times 4 is the same thing as 2. Plus 1 is still there, and we can simplify this to y is equal to 3. In a previous step, we found x was equal to 4, and in this step, we found that y was equal to 3, which means we have what we need to find the point of intersection. The fourth step is to state our solution as a point. We determined x was 4 and y was 3. Therefore, the solution, or point of intersection, is 4 and 3. The fifth step is to check your solution with the left side or right side check. However, we're not going to cover that in this lesson. Therefore, you can find a point of intersection with a table of values, a graph, or the method of substitution.